Lesson 9.9 is on graphing linear inequalities. I'm going to take a look at some of the symbols that you have to be familiar with. This is the greater than symbol, greater than or equal to when you add the part of the equality symbol, less than, and less than or equal to. The first example we're going to look at is using a less than symbol, and we'll graph the equation y is less than 2x plus 1. And we'll make an xy chart. Kind of follow the same format for each of these. And because I'm going to zoom in on this graph, I'm going to use some low values, some smaller values for y to produce some smaller values for x, or vice versa, I should say that. Small values for x. Always nice to use 0. And when x is 0, 1 comes out. If x is 1, we would do 2 times 1 plus 1, which would be 3. And if x is 2, we would do 2 times 2 plus 1, which gives us 5. So our coordinates are 0, 1, and I'm going to zoom in on this a little bit here so I can get it on the graph a bit better. Go over 0, up 1. Then 1, 3, go over 1, up 3. And over 2, up 5. And we should see a straight line, which we do. Now because this was a less than, we can't include the line because the line is not part of the solution. So to indicate that the line is not part of the solution, we're going to draw a dotted line to go through these points. And because the value for y has to be less than, it can be anything in this whole region here. But we can't include the line, which is why we have the dotted part indicating that the solutions don't lie on the line. But anything below the hash mark that we put in, I'll put that in a different color. Anything below that hash mark would be part of the solution. So that's kind of the format that we'll use for the rest of the presentation. Very similar to lesson is if you have something that says that the function is either less than or equal to, so we'll try y is less than or equal to negative 3x minus 2, just to change it up a little bit. Same idea, we use an xy chart. Let x be 0, then y would be negative 2. If x is 1, we get negative 5. If x is 3, then we get negative 11. This is going to be, you get a pretty extreme value there relative to this chart for the last set, but we'll try to get it on there. So I go over 0, down negative 2, over 1, down 5, over 3, down 11. And because this was, it was an equality, or it was included in equals, it can be less than or equal to, we'll draw a solid line. So that's the difference between just less than and the less than or equal to inequality, because we have this part of it can be equal to, so it can include the line, but the value for y is still in the less than part. So it's going to be this section here. It has to be sort of below the line. Now this is a negative slope, so it's going downhill. So you're just kind of seeing the two different kind of cases we can have. Let's take a look at the greater than possibilities. I wanted to show you what happens if you get an inequality that's not in slope-intercept form, just to remind you that you sometimes have to do some manipulations. Y minus 2 is greater than 3x. It's not slope-intercept form because we want to have just y on the left side, so we have to add 2 to both sides, which produces y is greater than 3x. Plus 2, and now we're ready for the xy chart. If x is 0, y is 2. If x is 1, y is 5. If x is 2, you do 3 times 2 is 6, plus 2 gives you 8. So now we know what to graph, and we know because we have the greater than, but not greater than or equal to, it should just be represented with a hash line or a dotted line. Oh, sorry, get rid of that. So we're going to put in 0, 2, over 0 up 2, over 1 up 5, over 2 and up 8. And we're going to use a dotted line on that and shade in the region below. Should be here. Oops, that's wrong. Should be the region above. I forgot we're doing a greater than. See if I can get that to clear off of here. Okay, that's the region we should be shading in. I should be shading that part in. Everything that we see. Okay, so that's the greater than. For the example for greater than or equal to, again, I want to start with an inequality that's not in slope-intercept form, just to demonstrate how you'd have to move it around a little bit. Let's try 2y, or how you have to manipulate it. 2y is greater than or equal to 4x plus 2. Now, what makes this not be slope-intercept form is the coefficient 2 in front of the y. So we have to make that a 1 by dividing by 2. And if you do, the property of equality says whatever you do to the left side, you have to do to the right side. And you have to, when you do division or multiplication, you have to do that to everything, both terms over here. So you have to divide the 4x by 2 and also the constant 2 by 2. So here we get y. 4 divided by 2 is 2, so it's 2x, and 2 divided by 2 is 1. So 2y is greater than or equal to 4x plus 2 is the same statement as y is greater than or equal to 2x plus 1. So now we can do the xy chart and put in 0, and out comes 1, put in 1, and we get 3, and put in 2, and we get 5, and then we graph that. And this isn't. Think about whether there should be a hash mark or a dotted line, or it should be a solid line. Once we put it in here, I'm getting a little smaller there. So you can see the values. So we're going to put in over 0 up 1, over 1 up 3, over 2 up 5, and hope you were thinking solid line. And because it's a greater than, everything above the line gets shaded. It's lots of fun, actually. Some of you will really enjoy doing this. It's almost like artwork. But you have to figure out what your parameters are. And that's basically it. You make sure your inequalities in slope-intercept form. You treat it almost like an equality. Do an xy chart. Make a decision about whether, when you connect the points, it should be with a dotted line or a solid line, based on whether it's something like that compared to that, or this. This would be dotted, this would be solid. This would be dotted, this would be solid. And this is above the line, because it's a greater than, and this would be below the line, because y is less than something.